In this particular video, we are going to look into why an image is not clear sometimes and what can we do to restore the image. So sometimes the video is not clear. It can be due to motion blur, that is the subject is moving, or otherwise it could be due to out of focus blur. Example, out of focus as in here focus is not being created on the image, or sometimes it can be due to atmospheric blur, like for example light rays which are being passed. So this is being used in astronomy, this kind of a blur. So now these are the three reasons uh, why we do not have the right image. And in all these types of images, here motion blur. Now, in all these kinds of images, we have something known as the point spread function. Now, point spread function indicates how the point has spread after degradation. If I calculate this point spread function well, I will know how can I restore my image the right way. It's only if I know the damage, I can restore my image. So this is that particular idea. So PSF describes how the point is spreading after degradation. So motion blur is a 1D or a 2D line segment. It basically creates a line segment across images. See, as you can see here, it has created some line segments across images. Then there is out of focus blur. So now out of focus blur basically causes a circular point PSF shape like this, some kind of a circular, because it is out of focus blur. And then there is atmospheric blur. Now this causes Gaussian distribution. And now these are the different kinds of blur that can be introduced in an image. So motion blur will have a line segment as its PSF shape. The second one is out of focus, that will have circular, and the last one is uh, uh, atmospheric, that will have a Gaussian distribution as its PSF shape. Now, how can we restore the image? So the function that is given is Fourier transform of the image plus the degraded function plus whatever is the noise spectrum, that will give me the degraded image spectrum. So Fourier transform of the image plus the degraded function plus the noise spectrum, and that will give us the degraded image spectrum. Now to calculate, first of all, this is G. G is nothing but my degraded image. If I can pass that degraded image by the degraded function, I will get the original image back. That's the whole idea of this restoration. I have the degraded image spectrum. To that, I give the degraded function, and that will give me the original image. So, how do I get my degraded image spectrum? Fourier transform, degraded function plus the noise spectrum, and this G of u comma v divided by h of u comma v, this one degraded function will give me the original image. So that is one technique, which is the inverse filtering technique. The second one is Wiener filtering. Now in Wiener filtering, it is the most widely used method. Here I use an equation, and it helps to balance deblurring and noise suppression as well. Then we also have one more, constraint least squares method, which restores the image while maintaining its smoothness. So with the help of this constraint least squares method, we here it wants to find a restored image such that it minimizes restoration error while maintaining smoothness. Then there is also iterative restoration, which is based upon Richardson-Lucy algorithm or Landweber iteration. So after restoration also, we can check the image quality by calculating the mean squared error, or another one is peak signal to noise ratio. With the help of this peak signal to noise ratio, I can calculate is my restoration good enough or not. And Wiener filtering is preferred over inverse filtering because it removes blur while also it considers noise. Whereas inverse filtering will amplify noise and it slowly becomes unstable.